How you doing? You can sit wherever you want. Just don't sit within 3 feet of the next person.
Mr. Strauss.
Yep.
I done the extra credit.
Yep.
And you put it in Power School, but then it got taken out.
Okay, I'll take a look at it.
Yeah. What's up?
How was your spring break?
It was good. Pretty much stayed home. What'd you do?
The same thing.
The same thing.
I'll just play video games and watch TV.
What games you play?
Huh?
So what games you play?
Spider-Man 2K.
So you play PS4?
This one has better exclusive games. The only downside is just how loud it gets.
Yeah, I don't even know if Xbox has any games that PS4 can't play.
You know, it's almost like every time, like the Game Awards or whatever it's called, guaranteed a PlayStation game, like getting the game of the year. I think in 2020 it was The Last of Us 2. And then,
I don't even know that game.
yeah, it's kind of like a zombie apocalyptic,
Oh, yeah.
like apocalyptic type of thing. So then in my head, I'll do like the other one, PlayStation. But no, I'm waiting to get it down so I can buy me a PS5.
Oh yeah.
That's where all the fun starts.
See, I have just the old Xbox right now. Like, it's just the same thing to me. 'Cause I don't play that much. I still like to play.
I used to play on the Xbox. Xbox 360 and the Wii was like to me.
I used to play my Wii all the time.
My thing is, I had a Mario Kart with wheel, but we didn't have wheel. I was
Yeah.
Whoa.
I had the wheel,
Shit, there
but I
was
played it all the time.
Yeah, I think
Yeah.
4 days school, and we're going back 8:30.
Yeah, no more social distancing.
Rocking the chunks.
Oh, yeah. Got it.
Oh wait, I think you got to like every other season.
Oh, fuck, word.
Here, you can sit there and I'll sit here.
What about you, Zane? How was your spring break?
It was good. It was good. I was supposed to do like a bunch of homework and I did like 3 assignments.
Oh, shoot, your spring break. Oh my goodness.
I know. I got 21 missing math assignments right now. So we're cooling. Still got an A. It's whatever.
With 21 missing assignments?
Yeah, because like the assignments, you don't get the points marked up if you don't do them. Wish you guys cool. I test well enough. I still have an A in the class, so I'm just like doing them. Exam.
How many you taking?
Just minus stats.
That shouldn't have happened. It turned all those extra credits to 0. Why did that happen?
Wang's probably gonna be fine. I'll get like 3 or 4 now. Stats is rough. Like it's so easy, and then all of a sudden it's really hard.
Okay. All right, I fixed it. Clicked the wrong button. That's why it did it. I hate that when that happens because then I end up with like 16 emails from people going, hey, did you know? And it's good that you let me know, but then it's like, and like, do I respond to all 16 emails or I just respond to one person and then fix it, you know?
Excited. Saw you put it in. I was like, oh, sweet. And then I got a notification
Yeah.
from school. I went to it. I was like, what?
So the thing is, yeah. Yeah, it's fixed now.
I think what you should do is when stuff like that happens, you sound like
Yeah, the email. Yeah, the only tough thing is like with this digital day and age, like because of this, I mean, you get Canvas notifications for all your classes. You get emails, it just when you get too many emails, then what ends up happening is people just start twiddling them out. They're like, oh, another email, up, another email. I mean, I literally am getting 200 emails a day because people can't go up and ask questions in person. We got 3 minutes to go. All right. How was your break, Gerald? Yeah, did you do anything? Yeah. What are you playing? Some ways I'm glad I'm not teenagers nowadays because those video games are so much cooler than when I was a kid. I thought I was just playing nonstop. And I think back to some of the games I played, it's like, five.
Was it like Galaga, Donkey Kong, Super Mario?
Even before that, it's like Paw, you know. But yeah, I like Donkey Kong. I like Mario, but I didn't actually have a video game station. I had to go to my friend's house. So then they kicked me out. How you doing, Silas? How you doing, Cole?
Good.
Good. Did you have a nice break? Did you do anything
Yeah.
fun?
That homework that was due, can I use my thing on it?
Your thingy?
My like free homework slip?
Sure.
I didn't
just
even
email
know
me
that
back.
was an assignment.
Yeah, that's an assignment. Yeah, you can use it on that.
Do I just submit a picture of that then?
Just email me saying, hey, I want to use my homework assignment on that, and I'll take care of it. Yep.
If you turn in, does that mean you just have like, that's like your extension for it?
No, it just excuses it. It just wipes it
So
out.
if I don't have any missing homework, can I use that to get like, I turn like where I got 7 out of 10 ones, 10 out of 10 on?
Sure. There we go. That's the bell. You can start. So welcome back, everybody, from break. Hope you guys had a nice, restful spring break. Hopefully you didn't have too much homework in all your classes. I know that you had homework in this class, but it wasn't that, I mean, wasn't that bad. Probably took you about 20 minutes. So why did I make the homework due in the middle of the week? Why didn't I make the homework due like this morning? Because I was trying to pace it out for you guys, because what ends up happening is procrastinators of the world unite tomorrow. If you procrastinate, all of a sudden you get to Monday night and you're like, oh crap, I have English, I have math, I have science, and you can't get it all done. So I tried to help you out by making it due in the middle of spring break so that you'd get it done earlier. And then when you got the notification that it was late, then you would get it done earlier. So good job for those of you who got your homework in on time. That was awesome. And that's what I mean, like when I say like your success in school has nothing to do with your intelligence. You know, first of all of your intelligences are just fine. All of you have functioning brains. None of you have a dysfunctional brain. Your brains all function just fine. So really, success is dependent upon your organizational skills and your ability to put down your cell phones when you need to and get your homework done. So good job for those of you who got your homework done. If you didn't get your homework done, well, that's something you need to work on then, is time management. So let's go through the homework and start with number 1, because you had 1, 2, 3 A and B, 4 A and B on page 358. Okay, so why don't you get out your homework? And then we're going to get crack lacking. So for number 1, it says, what are you keeping? Which of the variables are held constant in Boyle's law? So in Boyle's law, you're changing the pressure and then measuring how the volume changes. So the answer to number 1 is T is held constant and the moles of gas is held constant. Remember, when you're doing an experiment, Josh, you're only allowed to change one thing. The one thing you are changing is the pressure. Welcome. Number 2. Number 2 just has a lot of words in there. So the key is to strip away the words and focus on the important info. So on number 2, it says we've got some oxygen gas at a pressure of 101 kPa. That's our initial pressure. Our volume is expanding from 5 to a volume of 10. So from 5 decimeters cubed to 10 decimeters cubed. The temperature is 25 degrees Celsius. However, here it says that the temperature is not changing, Cole. It says the temperature is constant. So we don't have to worry about the temperature because the temperature is not changing. They want us to find the new pressure. Okay. So then Boyle's law is P1, V1, P2, V2. I do my algebra to solve for P2. And another reason why I write down the info is so that I plug in the numbers in the correct location. So my P1 is up here. My V2 is down here. And then I just put it in my calculator milem and I calculate. And then I get my answer. But I'm not done yet, Brian, am I? Or am I? Vasquez, you there?
No, you're not.
No, you're not done. Because the last thing you'd have to do is you have to think about your answer. Does your answer make sense? So if you are going to squeeze a balloon and make your balloon smaller, if volume goes down, my pressure is going to go up, right? So the opposite is true. If I make my volume bigger, then my pressure should go down. So then I look at my calculator answer, Mason, and I say, does that make sense? My volume got bigger. Volume went up. So what should happen to pressure? It should go down. And did it go down? Yeah. Okay. We use calculators to do our math, but you still have to use your brain to think about whether that answer makes sense, okay? See if anybody's waiting around here in the waiting room. All right, number 3. So these are a little bit easier in that they're not word problems. So our initial volume is 844 cubic centimeters. The initial pressure is 98.5 kPa. We're trying to find the new volume, and it says we're going to change the pressure to atmospheric. And atmospheric pressure is 101.325 kPa. That's standard. So if they say standard pressure, it's 101.325 kPa. Like the equation. This time we're solving for V2. Plug in the numbers. And let's think about our answer here, okay? The pressure is going up, Defina. If the pressure is going up, it must mean that my volume is getting smaller, right? If you squeeze a balloon and make it smaller, the pressure must be going up. So whatever our final answer is, my volume must be getting smaller. And yep, my volume did get smaller. Yep, we got everybody, Antonio. All right, let's do one from number 4. If you want, I can do 3B, but let's just do one more here, okay? So we've got a volume of 338 cubic centimeters. Pressure is 6.1 kPa. D2, we don't know. And a P2, 104. That's always Boyle's law. We're solving for V2. Plug in the numbers. Just like the last one, the pressure's going up, so the volume must be going down. And sure enough, the volume went down. So if you didn't do your homework, I'll post some new problems for you guys to do. Because really you need to practice it in order to learn this stuff, right? You can't shoot free throws by watching someone else shoot free throws, can you, Zane? Zane? Oh, I thought maybe you fell asleep. Don't fall asleep. I know it's hard late in the day like this, but don't fall asleep. So again, if you want me to, I can do 4B. But I'll give you 10 to 15 seconds to look over your homework, see if there's another problem you want me to do. Otherwise, we'll move on to the notes. Get some fresh air in here. It'll wake you up, Zane. So any other questions on the homework? Tomorrow, we're going to do our last lab of the year. Okay, we're going to collect gas from butane, and then we're going to set it on fire. Okay, all right. So basically, this is kind of like almost the last lecture of the year. So let's just recap the two laws we have already. We got Charles' law, which is V1 over T1, V2 over T2. Pressure is constant. So we keep pressure constant, we change the temperature. We got Boyle's law. V1, P1, V2, P2. Here we keep temperature constant. So we got two laws, and then the next law we got here, Alexis, is Avogadro's. He changed the amount of gas. So he changed the moles of gas. So remember the symbol for moles is N. And so if we don't have any gas, whoa. If you don't have any gas, the volume is 0. I lost the feed. So if you don't have any gas, the volume is 0. If you increase the amount of gas, you increase the volume. So that's kind of not a shocker there. Okay. So volume and moles are related. So then the last equation we're going to do is we're going to combine all three of these laws together, Boyle's, Charles, and Avogadro's, into one beautiful equation called the ideal gas law. PV equals nRT. So P is pressure. Don't drink it. It'll make you sick. So pressure, V is pressure, V is volume, but volume has to be in liters. Okay, this is where it's a little bit different. And that before your volume could be any unit. Decimeters, centimeters, cubed, milliliters. But now, Gerald, your volume has to be in liters, okay, for this equation. For the other ones, for these other two, your volume can be in any unit, okay? But for the ideal gas equation, your volume must be in liters. N is moles, the number of moles of a gas. So do you have 3 moles, 4 moles, half a mole? How many moles of gas do you have? R is the universal gas constant. And just like Planck's constant, there are 2 values for R. 8.31 liters times kPa over moles Kelvin. Those are the units, okay? We always put units on our numbers. So R is 8.31. Okay, Wapia? R is 8.31. Just like pi is 3.14, R is 8.31. That's if you're in kPa. If you're going to be in atmospheres, it's 0.0821 liters atmospheres per mole Kelvin. So you have to decide what pressure units you're using. And temperature must be in Kelvin. That hasn't changed. Your temperature must always be in Kelvin. So how are we doing at home? Amir, any questions? You got this, Amir?
Yeah.
All right. I got 1 thumbs up from Julia. That's good. So 1 person understands it. That's good. I'll take that. 1 out of 20. I'm batting 10%. All right. So what do I mean by ideal gas law? So let me let's create a little chart here. Ideal versus real. Ideal gas versus real gas. Well, actually, I'm going to start a new page. Ideal gas. I'm going to draw a container versus real gas. So Silas, when you think of a gas, you probably think of spheres, right? Moving around a container. Now, an ideal gas, we assume they're just points. We call them point masses, meaning that they have no volume. They have mass, but no volume. So they take up no space. Okay, now you're probably saying, well, that's stupid. That makes no absolute sense. That's like saying Mr. Strauss weighs 160 pounds, but he doesn't take up any space. Obviously, gas particles have mass and volume, but we're going to pretend they don't. So an ideal gas is a point mass, whereas a real gas is not a point mass. Number one here. So a real gas has mass and volume. When you think of a gas, you think of these gas particles moving in random directions. But that's not the case. Gas particles actually do not move randomly. It's mostly random, but it's not entirely random. And the reason why is because the gas particles have a slight attraction to each other. So there's actually a little bit of attraction going on. And so if there's an attraction, then the gas particles are not moving entirely randomly. And then 3 perfect elastic collisions. Meaning when gas particles collide, no energy is lost. So when 2 gas particles bump into each other, no energy is lost. That's what's meant by an elastic collision. But in reality, collisions are inelastic. Energy is lost in the form of heat. So perfect elastic, no energy is lost. Inelastic, energy is lost. Okay. So I'm just going to prove that to you right now. When your hands collide, right? Clap your hands together, they get warm. So when 2 things collide, they always generate heat. Okay, they always generate heat. So when these gas particles are colliding, when those guys are colliding, they should be generating heat, but we're going to pretend that they don't. Okay. And then the ideal gas equation. PV equals nRT. So to try to kind of give you an analogy here between what I mean by ideal and real, take this for example, Milam, all right? All of us in our head has our ideal spouse in mind, our ideal partner, right? Your ideal partner 6'2", eyes of blue, likes to go hiking, take long walks on beach, loves puppies and dogs, and likes to play Fortnite. There you go. That's your ideal partner. Okay. I'm sorry to break this to you, Julia. Your ideal partner does not exist. Okay. It's an ideal, right? It's an ideal. In reality, you're going to be with somebody who, is probably 5'2" and eyes of mauve and hates Fortnite. All right. So there's your ideal and then there's reality. So this is the ideal. It doesn't exist. This is reality. Okay. So why would we have an equation that's based on something that's not real? Why not have a real gas equation? Well, we do have a real gas equation, and this is it. V minus NB times P plus A over N squared over V squared is equal to nRT. So you've got the real gas equation, and you've got the ideal gas equation. Now, you can easily tell that the real gas equation looks a lot uglier. So the ideal gas equation is a lot simpler to use. And the beauty of it is it gives you the exact same answer 99% of the time. So if it's 99% accurate, why not use the easier equation, even though it's based on something that's ideal? It's based on non-reality. So even though the ideal gas equation isn't perfect, we go with it because it's so much easier to use. So tomorrow's lab, you are going to be using the ideal gas equation, okay? You will never use the real gas equation. Even in AP Chem, we don't even really use it. We talk about it, but we don't use it. In college, you'll use it, but for our purposes, you're never gonna use it. Okay. Let's do one example problem here. Typically, we're trying to find pressure or volume. Any questions before I do the example problem? All right, so let's say, what is the pressure of 200 and, let's do, 185 milliliters of hydrogen gas at 75 kPa and 25 degrees Celsius. So what is the pressure of 185 milliliters of hydrogen gas at 75 kPa and 25 Celsius? So you want to write down I forgot one thing here. What is the pressure of 185 mils of 2 moles? I forgot to give you the moles. Sorry, Mason. Please forgive me. So what is the pressure of 185 milliliters of 2 moles of hydrogen gas at 75 kPa and 25 degrees Celsius? So first thing you want to do, Julia, is write down all of your info. I've got 185 mils. My moles, 2 moles of hydrogen gas. Oh, crappers. I want to find the pressure. I guess I'm out of practice. Just to let you know, Herberger, I'm going to keep lecturing until Zane's head hits the table. When he finally passes out, he goes wonk. His head hits the table, then I know it's time to stop. It's coming soon. All right, so do we use this equation? There's only one equation that's got moles in it. So it's not that one, it's not that one, it's got to be that one. So I know everything that I need to know. The only thing is temperature must always be in Kelvin. So I add 273. So Josh, add 273 to your temperature. So automatically convert that to Kelvin. And the other thing that's different now is my volume has to be in liters. So I convert that to liters. Okay. Do my algebra. Now, if the problem wants it in kPa, then you use the R value that's in kPas. If they want it in atmospheres, then you use the R value that's in atmospheres. Most of the time, it's going to be in kPas. So I've got 2 moles. I multiply it by 8.31. Liters kPa for moles times Kelvin times my temperature, and then divided by my volume. Late night, Zane? Doing your homework last night? Midnight, getting all your English, math, and science done the day before? The morning before? Good. So moles cancel with moles, liters cancel with liters, Kelvin cancels with Kelvin. The only unit that doesn't cancel is kPa. Then I'm going to put that into my calculator. You get a really big number, but you shouldn't be afraid of big numbers. If you know you've done your math right and your algebra right. But then I got to do my siggy figgies. 2 there, 3 there, 3 there, 3 there. So with 2 sig figs, I get 27,000 kPa. So that's some pretty high pressure. So tomorrow, the wilds are going to do the lab. The cats, you're going to watch 2 videos from Tyler DeWitt, and then work on, you're going to do 4 problems just like this, okay? So that's what you cats are going to do tomorrow, and your remote learners, okay? And then we'll flip-flop it on Thursday, all right? So let me show you one last thing here. Now, we would have done this in a normal year, but we don't have a normal year. So if you want to do this in Q4, I'll let you do it. If you're got a free period. And that is to silver plate a bottle. So I'm gonna do this after the AP exams are done, so probably the last week of May. So let me just show you what this looks like. Oh, I want to stop sharing. Oh, you don't need to look at me. So you take a bottle and then you silver plate it. So what I did is I took a Polish vodka bottle and I silver plated it. And like I said, we'll do this the last week of May. And I'll send out an email reminder if you want to do it. It's just a fun lap. So no homework, no math problems to do. It's just come on in and you bring a small little bottle. I've got small little bottles if you don't have one. Unfortunately, you know, a lot of times the bottles that look pretty cool are like Coke bottles, or I shouldn't say unfortunately, Coke bottles look cool, perfume bottles look cool. The bottles that actually look pretty cool are, now why can't I think of the name of it? I just lost my mind. It's not Dos Equis, but the other Mexican beer that people, no, not Modelo.
Corona.
Corona, yeah, that's it. Corona bottles. They look cool when they're silver plated. But Coke bottles look pretty cool too. So like I said, if you want to do this in the last week of May, I'll send an email reminder out, and then you can just come in during a free period and silver plate a bottle. Like I said, kind of a fun lab to do. So. And then if you didn't do your homework, I'm gonna put 4 different problems in there for you to do. So then you can do those tonight, because there's not gonna be homework tonight. Let's see, we're almost to office hours. You guys have any questions at home? So tomorrow, like I said, you'll watch 2 videos from Tyler DeWitt, and then you'll have about 4 problems to do. If you didn't do the homework over break, I'll upload 4 new problems for you right now. Okay. No questions? All right, that means we've got plenty of time then for Mason to sing his favorite songs from the musical Cats. All right, Mason. Oh, we got a bad connection. Oh, sorry. So if you want to log out, you can go right ahead. If you need help with homework, I will stay on for office hours. Okay? I will hand you guys the lab.
Hey, Mr. Strauss.
What's that? Yeah, what's up?
Did you give me credit for the extra credit assignment?
Yeah, I did. There was a little glitch with Power School. So
So in Canvas, it looked like I got a 0 out of 0 for it.
yeah, in Canvas, it is a 0 out of 0, but in Power School, it's a 15. And then it's 15 out of 0 in Canvas. I mean, in
Okay.
Power School.
Okay,
So
thank
it's the
you.
power school, it's the power school, that one that matters, okay?
Yeah, gotcha.
Marlon, you got a question?
Oh yeah, actually, I was wondering if I could use one of my homework passes because I forgot to ask about that.
Yeah, you can. Just email me and say which assignment you want to use it for.
Okay, thanks.
All right, Herberger. Oh, Defina, do you have a question?
No.
Okay. So I'm just going to explain the lab to these guys while, oh, she took off. That's fine. All right. So